Hey, this is Mr. Smith here, and we are talking about radians and angular displacement today. And to help us with this, we've got this little spinning disk, and we've got a little ladybug and a beetle here. And so we're going to use this first to try and define what is a radian. And so some of you maybe have already studied this, and some of you maybe haven't, but it's going to be important for us to understand what a radian actually is. So I'm going to start tracing out this path that the beetle makes. And I'm going to stop tracing when I get to this dot. And I've already marked that out as one length of a radius. So from here to here, that distance, I can click on this ruler and show you, is 4 centimeters. So the radius of this circle right here is 4 centimeters. And so to mark out one radius, we just follow that little ladybug along until she's traveled that same exact distance. So again, if I started here and followed her along, I'd go until I hit 4 centimeters. And once I get to that 4 centimeter mark, then that is marking out one radius. And so I can connect this to the center right here. I can define this angle right here as 1 radian. So that is how you define 1 radian. You might notice it wouldn't matter what the radius actually is. So this little beetle here has a radius of 2 centimeters. And so I'd follow along with the beetle until I went 2 centimeters. And that 2 centimeter mark would be right on that same angle. And so I can have this defined by any radius. It's the same angle all the time. And so that is super convenient. So if I know that this is one radius, if I know that's 4 centimeters, and I know that this is 4 centimeters, okay, the length that beetle travels in one radius, then converting that into a distance, sometimes we'll call that a translational distance or displacement instead of rotational, okay, is going to be easy. So for example, if I keep going with this ladybug, let's say I go 2 radians now, and maybe I'm going to go to 3 radians. So my angle from where I started all the way over here to where I stopped, okay, right here, that is now 3 radians because I followed that beetle along 3 whole radiuses around that circle. So this would be 3 radians. And now if I want to turn that into a distance, how far did that beetle actually go? It's really easy as long as I measure my angle in radiuses, and this is called an arc length, and we usually use a symbol S to define that arc length. That arc length is just going to be my angular displacement. How much of an angle did I spin around in a circle with? Okay, times the radius. And so it's really easy. That's why we use radians in physics for this rotational stuff, because it makes all the conversions much, much simpler. So in this case, I want to know maybe how far did that beetle go. All I have to do is take my degrees that I traveled in radians, in this case, 3 radians, and multiply it by the length of the radius, and that was 4 centimeters. So I'm just going to stick with centimeters here just to make this easy, but usually we'll convert that to meters. Doesn't matter, works out in this case. And so my arc length turns out just to be 12 centimeters. Now, a lot of times you travel 3.5 radians or 2.78 radians or who knows. It doesn't matter. You just take that degree in radians and multiply it by the radius, and that's the distance that you travel. Okay, so that's super convenient and an easy way to convert our angular displacement, or how much of an angle have we rotated, into a distance in meters or centimeters or whatever unit you're actually going with. Okay, so that is one thing that we had to know, how to convert radians into meters. Another thing that we have to do is be able to convert from degrees to radians to revolutions. A lot of times we'll have problems that says, something spins around 4.5 revolutions, or you get angular velocity in or revolutions per minute. That's pretty common. And so we have to be able to convert from that. Well, the fact that, again, the radius, the length of the radius defines the radian. Okay, so again, let's look at 1 radian. It comes up to right here. Right now, that ladybug from this origin up to here traveled the same distance as what the radius is. Okay, right here, 1 radian means that you would travel 2 pi radians all the way around the circle. 2 pi equals about 6.28. And so if you count, how many radiuses there are, I've marked these out. Here's 1, 2, 3, okay, all the way to over here, 4, 5, 6, and then just this little bit extra here is the 0.28. And so it really does work out. 2 pi radiuses makes it all the way around the circle, or 6.28 radiuses or radians makes it all the way around the circle. So our conversion here is just going to be 2 pi radians equals 360 degrees, and 2 pi radians equals 1 revolution. And so those are our conversion factors for converting between radians and degrees and revolutions. So I'm going to go to just a whiteboard here and let's do a sample problem, and that'll be all we need to do for this video. Okay, so let's say we have a problem where it says that something spins around 3.5 revolutions. Okay, so we need to just think about this just like any other dimensional analysis problem. So I would just write down 3.5 revolutions. I'd make a little box. Normally you don't have to do this, but just to give you an idea, it's the same kind of process if we were converting from kilometers per second to miles per hour to meters per second. I'd take any of these conversions that I know, I'd put 1 on the top and 1 on the bottom. It's just like multiplying it by 1. So I want revolutions into radians. And so I'm going to know that 2 pi radians equals 1 revolution. And so I'm going to try and cancel the revolution on the bottom down here, and I'd write 2 pi radians on top. Now I'm sure in math class or other places you probably kind of converted this into pi radians equals a half a revolution, or pi radians equals 180 degrees. And you can certainly do that if you want to simplify it a little bit. But I just stick with these, and they never fail me, and I don't ever have to kind of worry about the extra work in those conversions. So that's what I do. And if you're comfortable with something else, feel free to do that. But once I know that I've got 2 pi radians for 1 revolution, and my units of revolution are going to cancel, I can just take 2 pi times 3.5. So 2 times 3.14 times 3.5 on my trusty calculator here gives me 21.98. So I'm just going to round that to 22 radians. I don't add the pi in, I multiplied that through on my calculator, and so I'm getting the actual value in radians. And in physics class, okay, and this may be a little bit different, and you still might see it, but in physics class, we want an actual number of radians. We normally don't want to include pi in our answer. So even if it's a decimal place or a weird number, and it would be a lot easier to throw a pi in there, because we're going to be working with these numbers in different ways in the future, we want just a number. We don't want the pi left in there. So that's how I'd convert to revolutions if I was, I'm sorry, from revolutions to radians. If I was doing degrees, it'd be the same exact way. So let's kind of erase this here and do one quick conversion from degrees into radians. Normally we're converting into radians because that's what we're going to be working with the most. But you can use this to go the other way. But let's just pick a angle. 60 degrees is a popular one. And so let's convert that into radians. And so I do the same thing. I just think about this like a normal kind of conversion that I would do with anything else. I know that 2 pi radians equals 360 degrees. I want to cancel out the degree symbol. So I have 360 degrees on the bottom. I'd have 2 pi radians on top. Again, a lot of you are going to be really comfortable with pi radians and 180 degrees, and that's one less button you have to push. So go for it. But we'll just do it like this. So I cancel out the degrees here, and I just multiply it through. So I'm going to say 60 multiplied by 2 multiplied by pi, or 3.14, and then divided by 360. And I get 1.05 radians. And so my answer to this would be 1.05 radians. Again, I don't have my pi here. I multiplied through with that on the calculator, and this is my final answer.